Chapter 2, Section 3, Volumes Adept. More complicated problems. Well, as we go through these problems, you'll find that they're really not that complicated. Number 1, it says the diameter and height of a cylinder are 4 centimeters and 4.5 centimeters respectively. Seems pretty straightforward. If a cone of equal diameter and height is stacked on top of the cylinder, what is the total volume? Okay, so we have a couple of shapes going on here, so it's probably a good idea to draw a picture. So the diameter and height, well, they're not quite the same, but for the picture I don't really care. So I'm just going to draw a cylinder here. Something like that. I can put something like that. And it's going to label it. If the diameter is 4, okay, I know immediately that the radius is 2 centimeters. Okay, and the height is 4.5. I guess I could have said h equals, but oh well. But we're told that a cone, equal diameter and equal height, is stacked on top. So it's going to fit perfectly on this blue circle here. And it's going to stand just as tall, like that. Okay, and there we go. This is the height, not the slant height. This is the actual height, and it is the same. So I'm going to label that as h. It'd be 2 different h's. This is 4.5 centimeters. And of course, this radius is the same. I'm not even going to bother labeling that. Okay, so what's the total combined? In fact, it wouldn't matter whether these were stacked together or not. It wouldn't change the volume at all. But let's work it out. Okay. Now, before I work this out, I'm going to fix my labeling here just to be really clear. I'm going to call this R1, and I'll call this H1. Again, they are going to be the same, but when I write everything out using different colors, I want the labeling to be consistent. So this is going to be H2. All right, and then of course this is the same. So R2, that's 2 centimeters. Okay. All right, so let's find the volume. So V equals pi R1 squared times H1. So that's the radius and the height of the cylinder, plus, well, the volume of the cone. And that would be 1/3 times pi times R2 squared times H2. Okay, so I'm just going to plug everything in, or substitute. Pi times 2 centimeters squared times 4.5 centimeters. Just going to write this below here. And in red, 1/3 times pi times 2.0 centimeters squared times 4.5 centimeters. All right. Take my calculator. Working it out, I get approximately 75.4, and this is a volume, so that's cubic centimeters. Here, I'll box this one. So that's our answer to the nearest tenth. Number 2. A sphere of radius 1 centimeter is cut into 8 equal pieces. What is the total volume of 5 pieces? Well, there's a couple different ways to approach this problem. One way is to just find the volume of the sphere as a number, cut that into 8 pieces, so you just divide that by 8, and then multiply it by 5. That's one way. So I'll actually demo that one. So the volume of a sphere, okay, so it's not cut, it's a complete sphere. That's 4/3 times pi times the radius cubed. Well, 1 cubed is just 1, so really it's just 4/3 times pi. So you get approximately 4.19, and this is centimeters cubed. Okay. But I'm going to leave this number displayed in my calculator, so I'm not going to actually clear it yet. And so if we divide it by 8, so this is the volume of one piece. Okay. So that would just be my 4.19 centimeters cubed divided by 8. Now I'm not actually going to use this number here. I'm going to use the original value that's still in my calculator, because this, after all, has been rounded. There we go. So divide that by 8, and that gives me 0.524 centimeters cubed. Okay, so that's the volume of one piece. And now just find the volume of 5 pieces. The volume of 5 pieces. Okay, so this number, though rounded, I still have that original answer in my calculator, so I haven't cleared it yet. So that would be this number here times 5. Multiply that by 5, and I get approximately 2.6. So now I'll go to the nearest tenth, and this is still centimeters cubed. All right, so that is one way to get our answer. Another approach to this same problem would just be to manipulate the formula for a complete sphere and only use the numbers once. Here's what I mean by that. So the volume of 5 pieces, there we go. Okay. Since we're told that we're cutting it into 8 pieces, but we want the volume of 5, really what it's asking us is to find 5/8 of the volume of a complete sphere. So that's just 5/8 times what? Times the volume of the complete sphere. So this is 4/3 pi times the radius cubed. Okay. Of course, you can use your fraction button if you want. Okay. And lo and behold, you get the exact same answer, 2.6 centimeters cubed. So, 2 different options. This is a bit quicker, but both are perfectly acceptable.